So right Riemann sum, we're sketching, and that's an overestimate. So we need to draw out and figure out where to find our 3 right Riemann sums. How wide is each piece? If it goes from 1 to 7. Yes.
So if we, like it says calculator, can we use it to find
I don't know. Did you get it right that way if you guessed? Okay, so did they have the right answer on there?
No, because like
They didn't have the right answer. Okay. So Charlotte's saying I want to just hedge my bets and see, but I would be afraid that the right answer would be there. I mean, I guess it's nice they didn't have the right answer.
But then it's just overestimate.
Sure. So if you're using logic, yeah, you can definitely work through the problem that way. So that's good. Charlotte's saying if you missed that, she put the whole thing in the calculator and knew it was an overestimate, and let it calculate the integral and one of these values. So what's the difference? Oh, underestimate, overestimate. Oh, I see. It's because they're really close. So that's good. If you wanted to find it exactly, you would need to find 2 subintervals, and then you could just plug in for 3 values, right? So if you found it the absolute mathy way, then you would have said we've got from 1 to 3, and then 3 to 5, and 5 to 7. Each of those are 2, and you would do 2 times f of 3 plus 2 f of 5 plus 2 f of 7, and then calculate that out. But you also had to know it was an overestimate. I didn't read the problem all the way through. We had to know that too, so that was great. So I haven't plugged these in to a calculator, but y'all can find values, right? You can plug it in Y1 and then use the calculator to find value, value, value. It's just one keystroke. You don't have to keep pushing that thing to do that. Should I move on? Are you good here? Okay. I like that, Charlotte. Good strategy. 2. We know that we're given this integral from 0 to 1, midpoint Riemann sum. We can't do it the same way because we actually have to find this time, right? We know that this is given. We still could have figured that out. I don't know why they gave that to us. So midpoint sum, what do we need to use for the midpoint sum? So what would the midpoints be? So we're going from 1 to 2 or 0 to 1? 0 to 1 with 2 intervals. So how wide, what's our change in x? Is a half or 0.5. And then we had to use this value. So this would have been 1/4 and this would have been 3/4. So we would have said f of 1/4 plus 0.5 f of 3/4. And I like to write it down so I have something to calculate. If you can calculate that and subtract it from the value you're given, you can solve this problem. That's a thought through for this one. Need more? Want to work it out? Or you feel good we should move on? Spend some time on maybe the sigma math. Starts with 6. So this is fundamental theorem of calculus. Your mock exam had several questions that were fundamental theorem of calculus. How is this fundamental theorem of calculus? You can replace the x and then you think of it as the prime. And if you know it's the prime, you can set it equal to 0. You can graph it, find the zeros, and solve it. So that was all you needed to do for this one, is recognize that this value is the derivative. If you set this in the calculator equal to 0, and then you can look at it to see whether it increases, decreases, you can find that x value is one of these values. That would have been a. But fundamental theorem of calculus tells you what to pull out of this so that you know. 4. This is also known to be increasing for x. There's another word for that. Do you know what the other word is that says it's either increasing or decreasing? It has all the same direction, I guess, because I want that word to be familiar in case they throw that at you. It's monotonic, meaning one. So this is all increasing. Monotonic means it's either all increasing or all decreasing. That's good to know. We have a left Riemann sum using 4 subintervals indicated by the table. Obviously, this being the number 6 progress check, we're going to have a lot of the same kind of questions, and you won't have this quantity of questions on the exam, but this is a nice sort of variety of problems. This one's a left Riemann sum this time. The other one was also increasing. So if it's a left Riemann sum, is it an overestimate or an underestimate? Well, clearly it's an underestimate because that's the choice down here. But could you draw it and visualize it? Because I drew the last one. Okay. So I don't know how many people missed this one. Do you want to work through this or check their values? You let me know. I got some no's. You let me know if you got a yes. All right. Which of the following limits equal to this? So I did tell you I've got a circuit with some great directions that we'll look at closer to. So we'll spend a day on this right before the exam, so it's really fresh for you. But Leland and I talked through these yesterday, and these were the things that we found that were key points to look for in these problems. I don't think that you would have one of these like an FRQ, so you should be able to compare these in different ways. So first we want to look at the interval. This is from 1 to 3. So when you think about the average value that we've done a bunch of times, that subtracting these values gives you the change of x, and you're dividing by infinity because you're trying to get the smallest pieces you can to add them up to get the exact value. So this part represents change in x, and this is not it for A. This is not it for C because the difference between 1 and 3 is 2. So we're looking for B or C. Then the number that we're starting with on our graph is 1. So we have to start at 1, and that's between B and D. It's D because it starts at 1. And then it has the sign, and it puts a 1 in here to indicate where you're starting with your numbers. So let's look at the next one and see if we can spot those things. So looking at it backwards, this has a change in x that's 3. That doesn't really help us. Well, no, these two are not 3. This is from 2 to 5, and this is from 0 to 3. So A or B. Can you see that? Can I pick that out? Okay. So what else? Would this one starts at 2. So it's got to be B. That 2 plus moves our integral to starting at 2. And then we're going to start the iterations of summing and adding from there. Those two things. Can we pick out those maybe for the next one? I think we have one more. So again, already highlighted, so you already know, but this goes from 3 to 8. So we have these two choices, 5. And then which one starts at 3? None of them start at 3, but one of them really does start at 3. Which one? Obviously the green one, but you know, can you see it? Pick it out. Why does it start at 3? The original problem says, yeah, it's got that 1 in there. So if you add a 3 in there to the 1, you get 4. So the original function was 1 plus the x, which is the part that's the change part. This is the summation part that gets added over again. If you say I need to start at 3, then you've got 3 plus 1 is 4. And this has the width of your area you're trying to find. Does that help point out some things that would make these clear? All right. Take the derivative. This is straight up fundamental theorem of calculus. It doesn't have chain rule, so it's just the x replaced. So this one's very straightforward. I hope everyone got that one right. Here, it's too big, I can't see. We've got 2 line segments from 0 to x. H prime of 4. So h prime is equal to f of t, yes? So we're looking for, at 4, that's 5. So that's also a fundamental theorem of calculus. And one of those problems that if you know that rule and you write it down because you see this notation where it equals the integral, then if you write it as h prime equals f, you know to look at the graph, and this gives you time on other problems because it's that fast. I hope for you. This one is fundamental theorem of calculus. Plug this in and multiply by the derivative of the baby because it has chain rule. And I don't know what I just did there. There we go. So fundamental theorem of calculus. X cubed in here makes it x to the 6th, and then multiply by the derivative of this value. You could go through the whole process and find an antiderivative and then take a derivative, but this is much faster. So hopefully 10 was fast for you. Yes? Great. 11. Selected values are given. First derivative in the table above. Let f be the function defined by least possible number of critical points in the interval. So, trying to do this quickly. What does it say? Fundamental theorem of calculus. Since f, so see how they started with f is differentiable. It is continuous. You don't need that in a multiple choice, but FRQ you would. Intermediate value theorem. So if we just stated, thought of that as f prime equals h of t, then we can look at this change from negative to positive and positive to negative and say that it's going to cross 0 twice there. How about that? Does that make sense? We did a little bit of that in pre-calculus and more of that this year. 11. 12. Too big. That didn't really help. I feel like it's getting bigger. I don't understand. Okay. The graph is given. G again equals an integral, so G prime equals f of t. Which of the following intervals is the graph both decreasing and concave up? So we're looking for G. So its derivative is this graph. This is the derivative graph. So it's decreasing when f is negative, and it's concave up when f is increasing. So here. Whoa. This is the negative part, so that's decreasing, and then this is where it's concave up. This is where the graphing comes in that we said we would do more of, and we've done more of. Have we done enough? I feel like you saw one of these not that long ago on some assessment, and I thought y'all did okay, but how about 12? Poor Sarah, just listening to this, it's just me going, are y'all good? And then I go on. Are y'all good? Okay. Happy birthday, by the way. 13. The graph has a domain, what's the value of, from -1. So this one, you're finding area, and you get -1. These are regular shapes. You can find area of triangles, rectangles, etc. Write it down. Don't do it in your head. Obviously, if it's on paper, sketch on it. Make sure you use negative values. This one, you're given 0 to 2, 0 to 2, 0 to 2. You don't have to flip any of them over. Check things like that. Little details that would tell you whether you have to flip it over or not. And then if we're given these two guys, we have to multiply f by 3 and then subtract g and get 17. So this one should have been happy at the end that you got a simple one. This one are straight line, straight line, straight line, straight line. You can find the area of these even though it jumps because it's like unfenced area. You can still find the area because it's just the point right above it. So you don't have to have it continuous to find the area as long as there's no big gap, and there's not a gap. So this should have been 2. not D. Any of these that you want to go back and see? The Riemann sums, you're not going to have 3 in a row like that to help you remember those rules, but did we point out some stuff that's going to narrow it down for you? Okay. All right, any other questions with part A? I'm really not here by myself. I know it sounds like it. Okay, part B. So this one, y'all asked me some questions yesterday, and I really had to go write stuff on paper. I'm not an in the air math person. I wish that I was, but I like to write it down. So this one says f is differentiable function, f of 1 equals pi over 2, f prime equals this. What is the value of f of 3? What was the method that you used? Because I really like how they wrote this one out. And I'd be happy to show you on paper. Yes, let's do it on paper. Okay, let me write it down first. This says f of 1 equals pi over 2. And then f prime equals 3 arctan x squared minus 3x plus 2. We're looking for f of 3. Question mark. Okay, so paper. All right, so if we take an integral here, right, we would get f of x, right? All right, so if we do that, we would take the integral of this and we would evaluate it from, on the problem it said 1 to 3, and I forgot to put that on there. So 1 to 3. So this would be from 1 to 3. So before I write out what we need to do in the math, let me show you a reminder to the fundamental theorem of calculus, which is that the integral of this, so I'm going to write it out again, 1 to 3 arctan x squared minus 3x plus 2, that's equal to the antiderivative of 3 minus the antiderivative of 1. How about that? Do we already know something in the given information? Yeah, we know this. So what if I said f of 3 equals pi over 2? If I put this on the other side, it's positive. It says minus pi over 2, and it would be positive on this side. And then I can put this in the calculator and figure it out. So do you know how to put this in the calculator? Because this was a calculator problem. So then you would totally just put in 3, and then arctangent's going to be this, and then you type the rest of it in. Find the integral from 1 to 3, which the calculator will do easily, and add pi over 2 to it. But this is really straightforward. How about that? Do you like it? I like it a lot. I'm sure my figuring it out would have been kind of me thinking through it and adding and subtracting, and I don't know. This is the fundamental theorem of calculus. Very plain. I didn't actually solve it on paper. Do you need me to, or could you do it now that we have the setup? They nodded their heads. I'm going on. 2. All right, this one. Again, I'm thinking, how do you put this on a calculator? It says a calculator icon, so it's in the calculator section. What did y'all do? Those of you who did this problem? Did you write it down? Did it make sense? Should we do it? Okay. So let's do it. Here's the problem. They want us to find the integral, and I can't put this in my calculator. I don't know what g is. There's no g of x button. It doesn't know what that is. So if I look at it closely, I recognize that there's a function here with a baby, and its baby's derivative has this in it. Do you see it? So if I go over here and go u equals 2 times g of x plus 1, then du dx equals 2, keep the front number, and then g prime of x. So du over 2 g prime of x equals dx. What do you do with that? You just hope that something good happens. I've got g prime of x. Nothing happened there. I'm just rewriting. I've got cosine squared of u. And instead of dx, I'm going to write du over 2g prime of x. Okay, that's gone. Now I can put this in my calculator. Except, what did I do that I still need to fix? Yeah, this is in terms of u. So I can either put this back in, but does that help me? No. So what do I do instead? What goes here? Because these are not in u. This is wrong. It's the new number. So you just take 0 and you put it here. And they gave us a chart, right? So they said g of 0 is 5. Back to paper. G of 0 is 5. That's 2 times 5 plus 1 is 11. How about that? So now the other value is 3. Look back at chart. 3. 3 is negative 2. So negative 2 times 2 is negative 4 plus 1 is negative 3, goes up here now. Negative 3. Can I put that in my calculator? Almost. What do I need to fix now? I need to go, this is negative and this is negative 3 to 11. And now this is in u, this is in u, these are in u and in the right order. And you can totally find the integral of that. If your calculator's on, it's much easier to do. So you would go, function is harder to put in, so make sure you can do cosine of x, parentheses, all squared, because you can't put the squared in the middle, right? So you need to know how to put it in your calculator. So this is the function, and I need my window to show those values or it won't find the integral. So I need to make sure I go from negative 3 at least to 11. And I could have put the negative 1/2 in there and calculated that way, and then I don't have to multiply by anything. I'm going to add that in there. Second, insert negative 0.5. Okay, graph. Because it's cosine squared, that part is positive, but then we just made it negative. That's why it's all under the axis. Now we can go second, and then 7 from negative 3 to 11. And then it finds the area for us. So that was a really multi-step problem. And before you could do any of it, you had to recognize, so that was negative 3.46. No, really. Oh, there we go. You had to notice that you couldn't put this in a calculator. Even though they told you to put it in a calculator, you had to do u substitution. You had to u substitute everything and then switch the integrals. Like, this was a lot. This was a lot in this problem. And if you didn't recognize what to do right away, then you need to leave it and come back to it when you can think about it. How about now? Could you spot some things that might help you get on the right path? Obviously, you can't put this in a calculator. Maybe you just need to write some stuff down and see if that leads you anywhere. They probably would have gotten you lots of space to write for this one. Okay, which is the following antiderivative? So we need to not take a derivative. We need to go up. So why wouldn't it be either A or B? Okay, well, there's a baby, and there's not a 2x times it, right? Well, this one has a 2x in the bottom. Antiderivative wouldn't have the baby that way. They would need, well, but that could be plus 0. This really isn't my favorite problem. So that wouldn't cancel. Sine of that times 2x. Yeah, I don't know that this would be a great, I see, I mean, I agree with you, Maya. There's not a plus c, so that's there, but again, the c could be 0. I haven't seen one quite so sketchy. Occasionally I see some sketchy ones on these PPCs. I've said that before. Because it looks like there could be 2. Like this might be one of those problems that says 1, 2, or 3, which are true. So we could have seen this with a plus c and then seen this. Because that one's just plugging in straight. This one doesn't have the t squared. Why wouldn't it be c? It would need the 2x, yeah. I don't like that problem. Okay, so this one I also thought was sketchy. I think if they give this on exam, they should probably give you a grid. Because it really looks like you should only evaluate these points. And finding the other values is difficult without a grid. Or like a ruler. But what they wanted us to do was use the fundamental theorem of calculus, which says we're going to plug in x squared into here and then multiply by 2x. So if you do that and you evaluate it 3 squared, because we plugged in x squared, is 9. We go to this graph and look at 9. The value is 4 times 2x, which is 2 times 3. So that makes the answer 24. So we're using the fundamental theorem of calculus, plugging in x squared. And I feel like they're trying too hard to trick us with these big fat dots. Whereas if they just put it on a grid, you could find your own points and know that they were true or not. U substitution, which is equivalent to the following. So 4x minus 3, 1/10. So what did they do here? You can't, we need to get rid of this x. That doesn't have an x. So when you plug that in, it makes another one. Is that it? Oh, they did a U and V substitution. Yeah, you have to go backwards and find x. Yeah. So was x equal to this, so you could make it another one? Isn't that to the 10th? To the 10th. Oh, it's because it's a plus there. Okay, my bad. Do I need to do on paper? Okay, paper. U equals 4x minus 3. And then the integral is x 4x minus 3 to the 10th. Paper. All right, so we've got u is this, and we need du dx equals 4, right? Yes? So that means that so far I have x times this part to the 10th, which is u to the 10th times du over 4. But I don't have everything in u. So how do I rearrange this so that I have x in terms of u? How much is u? I mean, how much is x in terms of u? Yeah, so u plus 3, right? U plus 3 equals 4x. U plus 3 over 4 equals x. So now we take this piece and we put it right there. So we have u plus 3 over 4 times u to the 10th du over 4. So if you multiply that through, I'll do that. I can take these numbers out. They said, so that's 1 over 16. And then that's u to the 11th plus 3u to the 10th du. So there was 2 substitutions. When you look at their notes, they make it a v substitution, which is weird and gross. It's easier to go the other way. So, and this was so small, I thought it said 1 over 10, so I can't even see. How about that? Does that make sense to you? Letter notation would have been parentheses here, but it got me to the answer. So we had to put it all in terms of u, like that problem we did way earlier with the 11 and the negative 3. What else? So this one's got u substitution. The e to the x cancels. This is the part that's the derivative of the baby. That's the negative 1/6. So you should be able to take the derivative here and make, they all have plus c. So once you see any problem with plus c, write it on your paper big. Okay, so you don't forget for later. Do I need to do this one? I'm going to say no. This one is complete the square. Anybody for complete the square? Complete the square going once, twice? Yes. All right, let's see it. So we have, why can't we do the a? Why isn't it a? It doesn't have negative 2x plus 6. Yeah. That's not a plain derivative. It's not a derivative that's a number, like 2 or 4. It has an x in it, and we don't have an x anywhere else, so it can't be that. So we just have to figure out which tangent it is. We've got x squared, negative x squared plus 6x minus 10. So back to paper. Here we go. That's going to be, I'm going to take out a negative from the bottom so that I have this, x squared minus 6x plus 10. When we complete the square in the same units, we're going to complete the square on these two guys, and we're going to put the 10 separately. So I'm thinking of x squared minus 6x and plus 10 is all by itself. What goes in the parentheses here? X minus 3. X minus 6 over 2. Then if we were to multiply this out, we'd have x squared minus 6x plus 9. And if we have plus 9, what do we have to do to the 10? Because if we add 9 to the one like one little piece, not on both sides of the equation, but if we add 9 to one side, we also have to subtract 9. Because that means we didn't really add anything to it at all, because that makes 0. We changed the equation by 0. So now we have, written pretty, negative 1 over this, x minus 3 squared, plus 1. This is tangent. You didn't have your note card out, but this is a PPC. You could have had your note card out. That would help you figure out which one of these to choose after that. It's going to be one of these two, and it's going to be this one. If you were using Charlotte's logic from before, and you have no idea how to start this problem, you might think through it and go, well, they only gave me one of these. It's probably not that one. And if you use Maya's logic, you've already canceled that one out. Then you look at these guys. You can't complete the square with the negative in the front, so it has to be one of these two. If you take the negative out and see that it's going to be minus 3, you would go with this one. Like, you could sort of talk yourself through it without doing complete the square if you had the time to think through it that way. You could do a little bit of math and help get you there, but that's how I would think through it. This is going to be arc sine because it's got the square root in the bottom. This is where you have to factor it out, which is hard. Would you like to see this one complete the square? Excellent. Let's do it. So, 10 square root of 8x minus 4x squared. So, this is a harder one for complete the square in my estimation. This is how I see it. It's 4 times 2x minus x squared. How am I doing so far? that okay? So this is where they got the 5. Who sees it? What happens? How do they get the 5 in those answers? Yeah, so the square root of 4, this is multiplication. So you can take this out and say this is 2 on the outside. And then 10 divided by 2 is the 5 that you get. So that's done. Now we're completing the square on this piece. So I need it to be, it's going to be backwards. So x and then 1 squared. And the reason for that is because I need it to be negative. Should I switch it out first? I probably should. How about if I switch the sign? So I've got sign looks like a value minus whatever squared. That's what my goal is. So if I take out the negative, I'm going to have x squared minus 2x. And I can complete the square on that. What's that? X minus what? 1. Yep, half of 2 is 1. 1 squared is plus 1. If I'm going to add a plus 1 to my equation, then I have to do, oh, but it's not really plus 1, is it? If there's a minus in the front, it looks like a plus 1, but then it's times minus 1, so it's really minus 1. That makes this a 1 in the front. So now this looks like arc sine. It's 1 minus something squared. This is a special something. That's why our arc sine has x minus 1 in it in the answer. Here's the 5. And then arc sine x minus 1 plus c. How about that? This is long division. We talked about this yesterday. If you divide this into the top, you end up with a remainder of 3. And then when you plug in 0 and 1, the first one cancels and you end up with 3 pi over 4. It's time to go, so I can't go through this, but we kind of went through it talking out loud yesterday. Hopefully you got that yesterday. There's 4 more here we can talk about after spring break. Please work on your 27 essential things so that they're not killing you the week we get back. Just a little bit, you know. I'm bored. I'm going to spend half an hour on calculus because Miss Haight really, really wants me to. But have a good time anyway. Okay, bye. Be safe.